Hello friends, welcome to my channel. So in this video I am going to explain you about that is the nuclear physics chapter, that is for NEET nuclear physics chapter, that is nuclear physics. In this, the first is I, that is stand for nucleus. A, it is nucleon. That nucleon, it contains proton and neutron, as you all know. So how to calculate the mass of that? That is, mass is equal to mp is equal to 1.67 into 10 to the power minus 27 kilogram. This is the mp, and it is equal to 1.007 mu is the value you will get for proton, and mn, that is for neutron. Mp, that is proton, okay, mass of proton. Mn is the mass of neutron. Neutron mass, that is 1.68 into 10 to the power minus 27 kilogram, that is 1.008 amu is the value you will get. And the another important formula, that is spin quantum number, that is plus or minus 1 by 2 is the formula. And spin angular momentum, that is plus or minus 1 by 2 into h by 2 pi is the formula. And some other formulas are there, like quark particle, that is up quark is equal to QUP plus or minus 2e by 3. Down quark, that is Q down is equal to plus or minus e by 3 is also there. Proton 2 up quark plus 1 down quark, that is equal to 2 into plus 2e by 3 plus 1 into minus e by 3, that is equal to plus c. And neutron, it is 1 up quark sorry 1 up quark plus 2 down quark, that is 1 plus 2e by 3 plus 2 into minus e by 3, that is equal to 0. Okay, you will get this is a formula, and some of the explanation they are given here. uh, the main important formulas, that is isotropic nucleus, that is z is equal to np is equal to same comma a difference, a is equal to difference. Isobaric nucleus, it is number of nucleons is same, that is equal to a. Number of protons is different here. Isobaric, number of protons is different, but in isotropic, number of protons is same but number of nucleons is different. In isotonic, or we can also say it as isoneutronic, say some number of neutrons is equal to same is equal to a minus z, so it is sum. And in mirror neutron, if number of protons is not equal to number of neutrons in position, then we can say it as mirror neutron. And isodiapher nucleus, that is difference of neutrons protons is same. Okay, means that is neutron and proton difference, it will be same. The difference that neutron and proton have, it will be same. Example, so you can see. And next is isostructure nucleus, that is having same number of atoms, same number of electrons. And isoelectronic, it has same number of electrons. Next is size of nucleus, that is radius. If you see radius of nucleus is inverse to the cube root of mass numbers, that is radius a into the power 1 by 3 radius of nucleus, like this. Rutherford's nuclear constant, here you can see. Or it can be volume. Nucleus behave as non-conducting solid sphere. Nucleus, it behaves as non-conducting solid sphere, that is Vnu is equal to 4 by 3 pi or Nu to the power 3. And this example they are given. Next, mass. So mass of nucleus is equal to mass of neutron, that is into mass of proton plus mass of neutron formula. And this is the main important formula. Mass of neutron is equal to zmp plus a minus z into mn. Leaving that, there is density formula is there. Density, that is equal to mass of nucleus by volume of nucleus. These are the important formula. Nuclear spin, it is similar to as ES nucleon will rotate about their own axis. The nucleons it rotate about their own axis. Nucleon it rotates on their own axis, and they pass a permanent angular momentum. He pass in permanent angular momentum, and hence the complete nucleus has some angular momentum. Also, we can say. And mass energy relation E is equal to mc square, where E is the energy corresponding to mass, mc square is the velocity of light, m is the c square to the power c square is the velocity of light, m is the part of mass which convert into energy. Energy corresponding to mass, 1 kg is equal to E is equal to 9 10 to the power 18 J. 1 m is equal to 931 MeV. Now, so here rest mass energy they have given proton mass energy of proton that is equal to 1 AMU, neutron 1 AMU that is 931 same, but for electron it is 9.18 10 to the power minus 31 that is equal to 1 by 108 1000 1 by 1836 that is if we convert into mass energy that is 0.51 MeV. Position also same, for photon it will be 0. Next is P they have asked. Relative energy plus that is total energy. So ER is equal to MOC square into 1 minus V square by C square into 1 by 2. Then we can add it. So ER is equal to MOC square plus 1 by 2 MOV square. ER is equal to R into M into E plus K into E, that is equal to ER is uh, is greater than or ME. Next, basic process definitions that are pair protection, that is called as high energy photon is absorbed by nucleus and configuration of nucleus remains unchanged, and nucleus emit pair of electrons and positions. Means high energy of photon is absorbed by nucleus and their configuration of nucleus it will not change, and nucleus it emits an pair of electron after absorbing that high energy of nucleus, they are saying. Okay, these are some of the note you can read it. Next is pair and palliation, that is electrons and position come closer, annihilate each other and release an energy in the form of radiation. So pairs and position it comes together, means it comes closer and it exhibits a energy in the form, it releases an energy that is in the form of radiation, it will be there. Okay, and for that they have given the formula here also, more number of formula they have given. And next they have given is P, that is photon is transfer its 100% energy to single electron. It is sufficient to remove the electron, then electron comes from the metal surface, effect is called as P. So the electrons photon it transfers the energy to the single electron, then it is the photon, the energy that is given by photon it is sufficient for that electron to come out from that metal surface, that is called as the PEE. Next is Compton effect, that is photon collide elastically with electron and transferred some part of its energy, and wavelength shift also it takes place. So photon it collides elastic with the electron, it collides and it get elastic with electron, and it also transfers some part of energy, and also your wavelength also will vary. If it transfers, so wavelength will also vary. Next is mass defect, that is mass of nucleus is slightly less from mass of nucleon. So this formula you have seen in the starting. Saw this formula, means I told you this formula. It is also an important formula. Questions may come to your NEET or any other exams also, like JEE also may come, and AIMS, many other exams, competitive exams. If you take physics in nuclear chapter, this question formula means question based on this formula may asked. Okay, so be careful. And binding energy also they may ask, that is binding energy means it requires to bond the nuclei in nucleus, so it requires the energy that bonds the nucleon in nucleus, or it removes the nucleon from the nucleus, so it also bonds the, it is an energy which which helps to bond the nucleon in the nucleus, or also it helps to remove the nucleon from the nucleus. Okay, both also it acts. So formula also please remember. So binding energy per nucleon. So it is the average energy that is required to remove the nucleon from the nucleus. That is single nucleon from the nucleus. Average energy. And binding energy curve you can see here. Okay. Leaving this curve, release energy in a nucleus. So they have given some formulas. These formulas you can ticket, so nothing important is there. Next is important is nuclear reaction. In this fission reaction is most important, that is it releases energy per fission, that is 200 MeV. Okay, release energy per nucleon per fission, that is equal to 200 by 235, that is equal to 0.8 MeV. Okay, note is there. Next it is a chain reaction. Here you can see, so chain is there. There is oxygen, neutron, barium, chromate. Okay, so like this chain it is having. And removal action, so some of the factors are they have given, so these are you have to read, it is difference they have given, so nothing is there for me to explain more. Fusion reaction, it is presence of high temperature and high pressure. Light nucleus comes closer and forms comparable mass nucleus. So light nucleus, if when in fusion reaction high temperature and high pressure is done, so where nucleus that are having come means that are very light, it will come together and forms a comparable mass nucleus. Okay, it joins together. Unstability of nucleus, some of the important information they have given here about the nucleus. So these are the reactions they have shown here for you. Reactions. So okay friends, only this much is there in this chapter, the important thing. So this all is you have to read. The most important explanation what they may ask in this means on which, like I said, formulas and explanation they may ask, and they may say tell us the which explanation it is, and formula like binding energy and many other formulas they may give questions, means they may give problems. So these are the important things that it may ask in this nuclear physics chapter for NEET or any competitive exams. So okay friends, see you in my next video with some other topics. Till then, take care, have a nice day, bye my dear friends.